Hello, good evening, all the people
Good evening.
who joined today.
Good evening, Ramnath.
Good evening, good evening. Thanks, Pradeep. I would like to thanks Pradeep like anything because he's just arranging the people like anything in a week or something. So I definitely I would like to say very much thanks to Pradeep.
Ramnath, not only Pradeep, we are also.
Okay. No, I will make the full sentence again. Thanks very much for Bimal to arrange a big meeting like us. No, we would like to discuss about some of the DevOps sessions or something. Thank you very much, Bimal. And all the people who have been doing it for like from the Ansible and the AWS and come until the DevOps. I'm very much happy that the people are continuing and to learn something like today. This I was just like having a dilemma that whether I should start doing the sessions on DevOps because I've been doing like Python for a couple of people. I've already done that, and for Ansible I have taken a batch for Pradeep and many people, as well as some other batches in India also. I just took that. So Ansible, Python, everything is going on Linux, which I used to do always, and AWS and Azure and Google Cloud, everything is going on. But DevOps, in the sense, it is going to be mostly of development and operations. So how we are going to fit into this environment? Because as I say that for the last 6 months, I've been talking to the team, like all the Sri Lankan team, that the people are coming from either from the networking background or from kind of a data center background, or some kind of people who are working in some kind of a data centers and ISP environments and other things. So how does it going to fit into that DevOps for them like that? Because the operations are coming up in this one. And because of the people are asking, like nowadays HR is asking about whether you know anything about the DevOps tools. Can you manage the DevOps things and other things? And because everything is going on nowadays in the cloud-based only. In the cloud-based only, in the sense we started not doing many kind of a thing on the physical side. Everything is on a software only, which is doing all these things. Even the firewalls, load balancers, and layer 7 firewalls, layer 7 like many other things, layer 7 load balancers and other things which we are doing there. Everything is on a software based nowadays. It's been doing. So when it is coming as a software based in the sense, how the machine has been constructed, how the load balancing has been working on, what all the things are required for us to create certain machines on a large scale. We've seen that in AWS, like that couple of machines are getting created automatically by the, AWS has got some features like that. So whenever there is a load is coming up, that machines will be getting started on its own like that. So we were wondering about that, how things are happening so quickly, and what is the mechanism behind that, and how we are going to control all these things in the sense. So when it comes to the AWS or Microsoft Azure or Google Cloud or any cloud which we are talking, there is a containerization is being talked very much. Containerization, virtualizations. Virtualization, we already been working on, whether we liked it or not. We already been working with a lot of virtualizations over there, and hypervisor we are working on Microsoft, as well as the VMware ESXi and the VMware workstations we are working on very heavily. And because all the machines has been installed in the VMware only, so porting is very easy. I mean, it's like migrating the things are very easier to the new machines or something. So these are all the things which makes us to move forward towards the containerization. We are actually from the virtualization backgrounds, because even though I am a pure networking guy who was working on Cisco and other networking products as well, but we've been working with many kind of a servers as well as the VMware environment. Even if I don't study that so properly about the virtual machines and other things and all, we used to do that. We are about to have it in the daily environment. So we need to learn about that. What is the hard disk size? What is the CPU size? And how much memory it has been allocated? What is the thin provisioning? What is the thick provisionings? Even if you don't like that, these things will be filling on your own ears like that. You start hearing about this, all these things in the environment where you are sitting and you are talking to the people. So virtualization is part of life, you can just say. So our virtualization, the same thing, same virtualization we are doing it in the machine creations on the AWS also. And as well as we, for the last 3-4 years, we've been talking about the containerizations. Containers, in the sense, they are just nothing but like a small applications which are having the the dependency files are integrated to it. Regardless of any OS platform, that container can run on that, something is going on. So it is very hard to understand those things because we are not from the software background or something, but we are in a position to maintain those containers as well as the servers in the virtualization environment and other things. It goes on like so many days we cannot just be leave behind those things that no, I do not want to know about that. Why should I learn those containerization, virtualizations and other things? Why should I know about the Dockers, containers, and the Kubernetes orchestration platforms, and the Ansible and Python? Ansible and Python, we are doing it for the network automations anyway, it is going on. And another major part is like automation things are coming up. So we are all doing the automations as well. In the automation, in the sense, it is only the scripting which was going on. I've been conducting the Ansible session for Pradeep and team for last 2 months we've been conducting the sessions and all. So like, whether we like it or not, we already been in the part of that revolution which has happened on the last 5 years, 6 years in the world over. Like containerization has been come up, automation has been come up. Automation has been in every other field, not only in the software field, is in the hardware field also. Automations are happening on OS platforms. Automations are happening on networking platforms, software platforms, and development platform. Everywhere the automation has been done. So automation, containerizations, virtualizations, and the operations, which is the development and operations, has come up. So that is a DevOps, which we normally call as. In this DevOps, my audience is also not a software engineers. And frankly speaking, that I am also not a software engineer, because I used to do the coding in the sense, whichever it has been already given to me, I'll just run the commands to see what is happening on the boxes like that. In between that, if you like to do some kind of a low-level troubleshooting in the sense, we'll be adding some kind of debug commands to that, running for certain timing only, because taking the downtime and running the debug commands and picking up all the informations and analyzing it, and then we'll be stopping the debug later. This much we know about what the software is doing doing the bad things for the hardware which has been running on, and how does it been affecting impacting the customer's network or something. So this much we know about that, because any hardware requires a software to run like that. So without a software, no hardware is going to run, something like that. So we need to understand the software side also. Like in that software, we are talking about most of Cisco OS, Juniper OS, Forti OS, or Palo Alto OS, Pan OS, we know what it called. And FI load balancer is also been there. They have got their own OS. So every other OS has been based on, luckily, on a Linux platform. So it's very easy to understand for us to know about how the infrastructure is going to be. Because it is basically taken, the Linux platform has been taken and it has been built up with the certain modules on that, like a routing module, or switching module, or the load balancing modules, or the firewall modules, like that. So the basic is nothing but a Linux. We just need to learn about the Linux to come into this kind of development and operation side. What is the DevOps? Why do we learn? What is it going to helpful for us as a network engineer, as a person who is working on a data centers only, as a person is working on mostly on an ISP environment only? How does it going to help this DevOps sessions and all? So that is a big question which was there with me for 2 years back also. Like, why should I learn those? What is going to cost me? Like, I am not going to do any kind of coding at all. I am not a coder at all. I don't know how to do the coding and all. What is the braces are coming up? What is the comma is coming up? Apostrophes coming up? Where do I go for, like, square bracket or normal bracket or something? Which one I should be using on this place? Like, so these are all the questions which were there in our mind, that we hate writing any kind of a code or something, because we are all born and like build and what do you say? We've been growing in that way, like, but the situation has been changed 3-4 years back, that they would like to mingle the support engineer as well as the development engineer into a one body like that. They do not want to keep it as like a separate. The person has to do the troubleshooting also. The person has to do some kind of a coding also. In between, there will be like a small, like a sandwich has been happened, like the coder as well as the troubleshooting implementation guy will be as a one person will be working on. So it's very easy for the companies to hire a person who knows both of the things, and he can do something on this. So that's how it has been happened. Now each and every field, the person need to know about some sort of a code. The coding is very much required for us to know, not only the commands. We are all working on I was working in Cisco and I was used to run them commands and like that. If I run into any problems like that, I just call up some of the developer engineers to talk to them, like a DE they call us. We just talk to them and they'll explain. We don't understand anything at all. Just ask that, give me the commands, and I'll run it and I'll get the like output and I'll give it to you. Let us go for analyzing like that. So that is not the case for now, at least I can say. You are in a position to know about that, how the code has been behaving, how the code has been written on that, and how the code can be written for our own requirement like that. Because we are going to talk about in this DevOps sessions, like everything is going to be mostly on an open source platform only. Open source in the sense, there is nobody is owning it, there is nobody is controlling it, and there is nobody is like going to take a control of it, something like nothing like that. Everybody is like, it's like a community. Everybody is working on that. Everybody is making some changes on this, and everyone is providing their own contributions towards that DevOps tools or something. It's that people are asked, people are being called for that. So that is the one that, because everything is based on the Linux platform, so we are all going to do the DevOps only. So it's about that the sandwich which happened like that. The person has to do the coding, has to do the how the code is working on, and how to do the implementations, and how to do the troubleshooting when the call comes from the customer. Like that, so there is a responsibility has been increased for a person to be staying on the troubleshooting side, should also know about the code. Where was the problem has come up in the sense, the person who doing the coding will not know how to implement it, and he doesn't know about that, how to troubleshoot them. The person who knows about the troubleshooting and implementing guy who doesn't know how to write the code. So they would like to pull the guy who is actually implementing and code, implementing and troubleshooting guy, to ask them to do some kind of a coding also, to ask them to learn them coding also like that. So they will be able to like they can make a person knows about everything or something. So because the environment is being demanding, the person has to know the coding, the person has to know the implementations, the person has to know the the troubleshooting side or something. How do you going to support the customer or something like that? So this is the market demand which has been going on. Even if you take the Cisco Nexus boxes, we can even customize the thing, the way that the switching is going to happen. We can do that. There is a lot of coding has been available for that. And when you talk about that, the boxes which are very famous boxes like the FI boxes, if you take that, we can write the codes on by using the I rules, it's possible. And even FI is also been nowadays been pulled into the Ansible platform to do the coding as well as the troubleshooting as well as for that. We are all using the Ansible automation for automating the FI implementations and the installations as well. We are doing that. Python has also been used in many other places like that. So whether you like it or not, you just need to go for some sort of a coding. Better to start with an Ansible and to go for a Python, then to come for a DevOps. That will be the better way that I can just say. It's my suggestion. The way I started, it was easy for me to understand things because Ansible work with the boxes which we already know. Cisco boxes, Juniper boxes, Nexus boxes, Fortinet boxes, and FI boxes and other things. Because we know that how the box is operating, what the primary work the box has been doing there, and what are the commands which we've been running on that, and how to get the short support, or how to see the interface summary, how to assign an IP address and other things which we know already because 6-7 years we've been working on those boxes. So automating those boxes is quite easier through the Ansible and Python rather than directly jumping into the DevOps and doing the writing the code directly on this. It is very, very hard. I'm telling you, very hard. It is not so hard that we cannot learn or something other, but it may take its own time because everything has got its own potential on that. So we just need to have that potential in our mind so that we can go for the DevOps and we can start learning on these things. So again, the people may be asking that I am not at all going to do any kind of a server operating systems or network operating systems management, or I am not going to create any container or virtualization. I'm going to do that. I will not be installing any applications or databases on this. Why should I learn the DevOps? This is a very $1 million question that people will be asking that. So again, I would like to tell them that on-premises is actually being, declining. The networks are declining nowadays. On-premises networks are going away. Going away in the sense like buying the physical equipments and installing it in the on-premises and tuning them, installing them, and going to maintain them. All these things are like slowly decreasing. The levels has been decreasing. The percentage level, if you see that, it's getting decreased. Then where all things are going on and how the people are working in an office? Everyone is connected to the cloud. Cloud in the sense either it is an AWS or maybe the Azure, mostly Azure, the people who are Windows platform people will be going to the Azure. And the Google Cloud has also been there. And the OpenStack has also been there. Many other things are going on in the field. So on-premises, which I was saying that the physical equipments are going away. There is no more physical equipments as such. Why they are not the physical equipments that people are not looking for? Because if you like to go for an expansion or something, there will be a lot of license issues. And there will be a lot of, and the number of people who are going to get increased on this, the traffic which is getting increased on this. And manipulating the traffic is not so easy because of everything is a proprietary platforms in that. We cannot go and modify the code which has been running on that side inside because we are not allowed to go in there because it's not been allowed at all because we cannot see the code how does it been running on this. So these are all the problems which are coming up with the hard-coded boxes which we are purchasing from the market and we are installing it as an on-premise. This was the trend which was there 10 years back and all that. Now it is not there. We are all installing the load balancers. We are all installing the firewalls in the in the cloud itself directly. How does it be working? How do we do that? Load balancing things. Nginx is another solution, perfect solution for cloud-based load balancing things. And Enginex is coming up so freely. It is free. You can install it in a machine and you can start working on that. It's very easier. There is no licensing required for that. And expansion is so huge and it is very easier to expand it. You don't need to look for any license as such. Like that, web server, if you're looking for that, you can go for Apache Tomcat. That is very easy to configure that. So like so many open source platforms has been so wide, wide variety of things are available in the cloud-based environment. We can go for an expansion plan so easily. That is what all the corporates are looking for. Expansion should be faster and it should be reliable and it should be done it in very quickly like that. Means they are looking for a project to be finished in a week or 2 weeks or 3 weeks or something. That is quite impossible when you go for when you're looking for a physical equipments need to get installed and tuned it according to our own requirement or something. So it is becoming like the whole world is moving towards a cloud-based environment in the sense we need to go for that kind of the skills we need to upgrade ourselves to be fit into the market so that we will be getting the proper jobs. At least if you like to look for a new job, you would like to jump into that, or you would like to ask for a raise or something in the current job or something like that, you require the skills for that to go for that. So the DevOps will help you. I'm telling you, I seen it in practically in my own life that it's helping us. And if you put that things of the DevOps tools, which these are all the tools which you know that in the sense, they're liking the resume and they are pulling the people inside because the demanding has been coming up to the cloud-based environments nowadays. What all not they are asking? They are asking everything whichever it has been. Yesterday introduced the tools also they are asking for us. So it is one way if you just see that how many things we are going to learn it. I started my career by just crimping the RJ45. You don't believe me. I did many of the cabling sites also. Sites with the cabling completely UTP and fiber cabling and all. I used to do that. Then we've been installing the operating systems and running the routers and other things, which I was doing that. Now I've been coming up to the DevOps in the sense means I'm started doing the coding on this. So whenever the market is responding, market is expecting us to do something like, so we are in a position to go for, to meet the requirement of the market which has been demanding. That's why the DevOps is also going to be helpful to you. I'm telling that word call also because your primary skill is going to be remaining as the same one, like you are a network guy, or you are a load balancing person, you are a routing guy, or you are a firewall person. You are good in a checkpoint firewall for 5 years, 6 years, you are an expert on this. So those things definitely it is going to help you. Definitely, I'm not saying that. That is your core skill. Additionally, what do you look for? You should be having an automation platform. You should know about that, either Ansible or Python. Then you should be knowing about some of the DevOps tools on this. DevOps in the sense, it's like a load balancers you should know, web servers you should know, and implementation projects like that. You'll have to go for a Jenkins or something like that. Software which has been there you should know. And Git and GitHub, you should know that. That is nothing but the collaboration way, like how you are going to share all the codes and other things. You should know that. Because every other company now started putting the codes, everything on a Git only. From the GitHub only, the people are pulling that particular projects and they start working on it. So the collaboration is quite easier. Cooperation is very easier because the The teams are nowadays, it has been a totally in a different geographical environments. So they work in some different time zones as well. So to collaborate between them, the Git and Github is working so beautifully so that we can able to work on that. Like many other things, we've been working on like data centers all over the world. I've been working with AWS many projects as well. Like that, I was working in Tokyo data centers and other things and all. So it is a part of life. So we should be ready to face the challenges whichever it is coming under containerizations or the load balancing skills which are coming up on the open source platforms and the cloud-based environments. Definitely we should be knowing that. So the undercurrent thing is that we just need to know about the DevOps also. I'm saying the word also because DevOps, whether it is going to bring you the job or something, I can say that yes, not 100%, but it's going to be an additional skill for you. And it is going to add a weightage to your resume that you know the DevOps tools also. And if they're asking you whether you can do the coding or something, you can just say that around 30-40% of the coding which I can understand, I can write something on that because I have some experiences on the Ansible as well as the Python also. So you can start coding also that because automation is a part of DevOps. DevOps in the sense of development and operations. We can look for the operation side. Operation side in the sense you are not going to do the heavy coding. Coders will be there. Coders in the sense of the software programmers who are the 100% ways are there. But you are in a position to going to implement those software applications into the client locations or something like that. So you just need to be in a position that you will be able to support that kind of software whichever there is giving the problems or something, and you should know how to implement the project. There are so many implementing things which we'll discuss, and we will be talking about the collaboration things we'll discuss, and the development platforms will be discussing on this, either the cloud or non-cloud or on-premises or local data center something we'll discuss. And the load balancing solutions we'll be discussing on this. Deployment features we'll be discussing that, how to deploy the code or something. Even Ansible has also been getting deployed over there because of so many projects which are running on this. So what I say, this is going to be an additional skills for the person who are working under the networking side with the core networking guy, 10 years plus, 10 plus, 12 plus experienced people and all. Everybody is coming with it nowadays. See, when you see that even if it is for a level 1, the guy who is going to be put in the freshers or 1 year experience, 2 years experience also, they are looking for a cloud experience for them. How do they get the cloud experience within 1 year? I don't understand, but still the HR is asking that whether you know AWS, whether you know, do you know the Azure, something like that. Because I was just getting some training requirement which is coming to me. They're asking for the people to be known because they just come out of the college in India. And the teams are asking that, like tell them how the AWS is operating, how the Azure is operating. I told them that to the masters, saying, they should know about what is a Linux server first. They should know what is a Windows server first, what is an AD, what is an LDAP, all these things. They say, yeah, just tell them, just half an hour. Then he's talk about cloud with those people. So this is what the environment we are facing currently now. Whether the person is able to take that, whether it is going to digest or not. Okay, so they have to learn everything. So that is the environment which has been coming up for the freshers itself. And I think that it's a team which they are today with me, maybe like around more than 6 years, 7 years of experience on the field. So we are bound to do that. We are about to do this, and as well as we have to do this one. Otherwise, your resume may be like rejected by many people, and in the current company also people will be looking for skills to go off, and you cannot be sticking to that same job for a while. And you may have to, if you are thinking to leave the job and go to jumping to the another job or something, you may require certain skills from the DevOps side. So this is about the introductions about the DevOps. So let me go through the things because the slides is so heavier that around 140 slides are there. I don't know whether I can complete all the slides or something because I prepared this for some other people and other things. But I would like to run it quite fastly, and I will be explaining things what is required for us to know that, because in the diagram you can see that there are so many things are there in this. We are not going to discuss everything on this. What is required for us from our field, what all things we may require, so importantly, what is the mandatory things that we just should be knowing in this. All these things I will be talking about that. And if you like to add any other tools which are used in your environment, in your network or something, in your client network or something, you can just inform me. I can try to include that. But whatever I'm going to discuss that today to you, or maybe in the sessions on this, What is required for us to know that I'm going to discuss it. It's not like specialized environment or something, because all over the world, the people are looking for the same thing. Okay, let me run through these slides. Be with me patiently. Okay. Devops topics. These are all the topics which I'm going to discuss. Okay. Okay, one second. Okay, let it be as it is. And this is the DevOps topics. Like, we have to go through the Linux basics first. These are all the diagrams which I took it from somewhere, from the internet only I take it. And Linux basics, without Linux, you will not be able to conduct any kind of, the DevOps in the sense, because you should be knowing about Linux very well. Very well in the sense, at least 60-70% of the internals you should be knowing about. Then you can go for the DevOps. Then people may be asking that whether I cannot do it in the Windows platform. Devops tools doesn't work in Windows platform. They'll be asking because they are all coming from the Windows background. Definitely they will be working on this, but development engineers, which all depend on Linux platforms only. So we need to learn about the Linux first. Linux basics, I'll just give it. I'm not going to do the entire system administration things on the Linux or something. I'm not going to do that. I'll be taking that Linux basics, whichever it is required for you to install, operate the DevOps tools in the Linux platform. That I will show you. Then, sorry, Git and GitHub, we just need to understand. I'm sorry. Then the Apache Tomcat, that is nothing but the web server, and many more things it can do. Nginx is one of the load balancer which we talk about. Maven is kind of software platform which we are going to discuss that. Jenkins is the deployment platform. Ansible, everyone knows that. We already done that Ansible. Ansible is like an automation product for the network. We are doing it for the network, but we can do it for the servers also. Docker and Kubernetes comes under the containerization platforms, containerization and the orchestrations like it comes. Terraform has been very widely used in all over the cloud that to implement the projects as well, like automating the projects on cloud platform. We are doing the Terraform. Sonarqube is being added extra. That is for verifying and troubleshooting your codes, how the code is operating there. So these are all the main things which I would like to discuss it with you people. I will be talking about the Linux basic first, at least for 3 to 4 sessions or maybe more than that. I would like to give you the complete Linux basics on that so that you will be able to do things very easily. Then Git and GitHub, we will be running on this. Apache Tomcat, Enginex, these are all very easier. But we will be seeing it through in the Linux platform only. Maven, Jenkins, Ansible, and Docker and Kubernetes. These are all completely, the code is been involved on this. Maybe like in Apache Tomcat and the Enginex, we will be configuring certain files only. We can do the web server and we can do the load balancing on this. Maven, Jenkins, we just need to know the interfaces like UI, that is a user interface need to be known, as well as a CLI, we just need to know that. So these are all I'll be talking about. Jenkins is a pure, deployment mode, deployment software, we can just call it as. Ansible, it is an automation. These two are the containerizations and other things. Terraform, like that, we will be discussing some other things on this one. Let me go to the next slide. Linux basics. Linux basics, what all things we'll be learning in the Linux operating system basics. You should know what is the operating system, how does it the Linux is operating, and what is the history of the Linux, and what are the flavors of Linux. Means like how many Linux platforms are there. We normally dividing into the 2 platforms. One is the Red Hat platform, another one is the Debian platform. Red Hat coming under like that, we just see the Red Hat is a like topmost one, which has been a very much highly sold platform. And CentOS is a clone of it, and Scientific Linux is a clone of it. Like that, many other clones are there in that. Like the Debian, if you just say Ubuntu, Linux Mint, and many other things are there. We will be talking about mostly on Ubuntu or in a CentOS, we'll be talking on. Red Hat and Debian are the most. And the difference between the Windows and the Linux platform, how do we differentiate? Understand the use of essential tools on Linux. Access a shell prompt and issue the commands with the correct syntax. Use the input and output redirections. Use the grep and regular expression to analyze the text. Access remote systems using the SSH. SSH we normally using that because we will be logging into the remote routers and switches using the SSH only. Login and switch user to the multi-user targets. Archive, compress, unpack, and uncompress the files using this kind of tar and zip and other things. We need to know that because we are going to install the software by using the star and a star and a gzip and other things. So basics in the sense, how do you log into the Linux server? How do you install the Linux server first? How do you log into that? What are the commands we are going to run on that? How the prompt will be looking like, CLI, how it will be looking like, what are the basic commands we just need to know. So these all we will be seeing that. And creating and editing the text files, create, delete, copy, and move files and directories. This is very much required because you need to work with the project directories as well, project files as well. List, set, and change the standard file and directory permissions. We just need to know because if you like to run a script, that is called as a shell script here. If you like to run a script in the sense, what are the permissions required? We just need to change them. Locate, read, and use system documentation, including man info and files, searching files, and like finding out the file where it is like that. So we do. Configuring the firewall settings using the firewall config and firewall command. We require to know them because we just need to open some certain ports for that the Devops tools can operate. Create, delete, and modify local user accounts and passwords. Creating the user and giving them the rights so that he can run the Devops tools in the Linux platform. Init run levels means shutting down the system, reboot the system, or something like we'll be doing all this. Init run levels we'll be talking. This is a Linux basics we'll be talking about. Linux, without knowing the Linux, you will not be able to do any kind of operations in the DevOps, I'm telling. So without knowing Linux, can I do the DevOps? People will be asking. Yes. Every other tool which I'm going to discuss it today can be operated, can be installed and worked in the Windows platform, but I don't recommend. That's what I'm telling. I don't recommend to learn the things through the Windows platform. Better you come to the Linux platform so that you will be able to last longer and you'll be able to interact with your programmers and the customers very easily. Because if you do through the Linux systems, initially it may be a frustrating thing, but later once things goes on, you'll start liking it, the commands and other things. Okay, anyway, that I will be talking on the session side. So Git and GitHub. Git and GitHub, what are Git and GitHub? Git is a free open source distributed version control system designed to handle everything from small to very large projects and speed and efficiency. GitHub is a web-based Git repository hosting service which offers all of the distributed version control and source code management functionality of the Git, as well as adding its own features. Git is like a local repository, means you will keep it in your computer. GitHub is nothing but a remote repository which has been kept in the internet. So you do the coding, you will edit that, you will finalize it, you will commit it, and you will be pushing it to the GitHub. Once it has been pushed to the GitHub, it has been available for all the people who are part of that project. They can pull that code and they can start working on that. So that's how all the Ansible and Python files we've been working on. Then what is GitHub? To be very crisp about what exactly is a GitHub, is a file or code sharing service. Is a highly used software that is typically used for version control. Version control in the sense, whenever there is an updation has been happened, the next version has come up. That is nothing but a version control. Say, for example, a software development team wants to build a website and everyone has to update their code simultaneously while working on the project. In this case, GitHub helps them to build the centralized repository where everyone can upload, edit, and manage the code files. This is what is been doing. GitHub, Git terminologies we just need to know. I'll take so extensively, no need to worry about that. We will be doing the 100% practicals on all the sessions which I'm going to conduct. I am not going to talk anything on only the theoretical based, which you will be definitely, losing that. Even after just finishing the class, you will lose all the theory because it doesn't go in our mind. Because we are all people are working on the keyboard like that. You just need to type all the commands to understand all this. So we will do all the labs to understand all these things, but you should be having the utmost patience to, to read, understand, do, redo, make mistakes, learn things like this. Is the steps involved in that. Anyway, Git terminologies with the repository, branches, forking, cloning, pull request, pushing, and committing. These are all the terminologies which we are going to discuss it in the Git and GitHub sessions. Repository is nothing but a storage. You can keep files, text files, images like this. And this is like a repository. So these are all the files are kept here, like a repository over here. Version 2, new file, version 1, like that will be keeping. Multiple people are writing it. It's the third commit, second commit, first commit means the first person entered, second person entered, third person entered. So there is a versions are kept on this link. So this is how it has been written on that. Okay. Branching is like a different versions of the repository at one time. Let's say you want to add a new feature and you are afraid of that same time whether to make changes to the main project or not. This is where Git branching is coming to the rescue. Means main code will be there. We'll be doing some branches on this. Once the branches are perfectly working on this, then we will go and merge for this. Like that. That is nothing but a branching. Then Git and Git branch and it is operations like this. And the Git branching and merging, we just need to go for a merging with the main project. We'll do that. Forking. Forking is a copy of repository that you manage. Let's make you changes to the project without affecting the original repository. Forking is nothing but you are just going to see the other code and the other whichever who has been written on that. You can use a pull request, means you are asking the person that you give it to me, the code, that I will be seeing the changes or something. That is nothing but a forking. And this is how the forking has been happening, like local repo, pushing, and other things will happen. Cloning. When you create a repository in github.com, it exists a remote repository. You can clone your repository to create a local copy. Means you are taking a copy of. That is nothing but a cloning. You can even clone any other persons who have shared his own codes publicly. Else, you just need to look for a permission from that person. So you can pull that code and you can do some modifications, or you can even use it out. We are all using that Ansible codes or everything has been given to us. So we will clone it to the local machine so that we will be doing all the automation things. Cloning is like hello and clone the hello, like that it's coming. Pull requests. It's like that you are going to pull all these things, git add, git commit, and other things we'll do. Pushing, once you finish all these things, means you've done your code, you've finished all your work, and you committed everything, like there is no much change going to happen on this one. It's a full furnished one, so you will push it to the remote repository. Like that. Pulling in the sense you're taking it, pushing in the sense you are giving it. Like that. Committing meaningful changes to the commits. Whenever you finish your work, you commit it, means you are finalizing it. This is the commits. Then we'll speak about Apache Tomcat. Apache Tomcat is a web server. Okay. It's a web server which has been running in a servlet container. This is a Java-based thing. So there are some dependencies are involved in this Apache Tomcat. We just need to install the dependencies in the Linux platform. I'll show you how to install it without having any issues at all. So once you install it, the Tomcat can be installed very easily. And whatever the tools we are going to discuss it, everything is going to be the open source tool. There is no license involved in anywhere. So we are very free to use anytime. How many times you would like to use, how much volume you are going to increase it, doesn't make any sense at all because there is no licensing plan in this one. So Tomcat is used as a web applications written in Java that don't require full Java, but still require a reliable tool because there is a web server and servlet container. Like that. It's a platform independent tool. You can even run Tomcat in Windows platform as well as in Linux platform. As long as there is a Java is installed, installation is a straightforward process. You just need to download the desired version from the official website and unpack and use it in the system. Where are all things will be going on this? This is how you'll be accessing HTTP localhost colon 8080. 8080, the port number is going to run on this Apache Tomcat server. By default, it will be running. You can change that. And for this, the 8080 need to be open in our firewall. So that I was talking about the Linux basics firewall opening and all everything. We just need to know that. Okay. This is how your screen will be looking at. Once Tomcat has been installed properly, you will be seeing this. The first initial screen, like the home page, you'll be seeing this. From here, you can do that. So our status you can see, managing the applications you can do, host manager you can do that. Means like creating a multiple Tomcat servers like that. Documentations you can visit from the, it will be going to the internet or it can be downloaded to the local machine or something, you can see that. And there are some key Tomcat directories: bin directory, conf directory, logs directory, webhooks directory. So these are all the directories which are getting done by default. It will be installed in that one. So we will learn about this. .sh files in the Linux platform, .bat files in the Windows platform, and the Tomcat, deployer, manager, host manager, reams and access control. What all tools are coming up with the Apache Tomcat? Deployer is nothing but deploy, pre-compile and validate web applications. Web apps, we can create that. manager, operating as a manager to web app to deploy, undeploy, redeploy, and other things. Host manager, web app, add and remove virtual hosts. Reams and access control. Database of the user's password. Who are all can manage the service? Like we can go and give the users, like permissions and other things. Difference between the Apache and Apache web server, because Apache web server has been using for quite a long time, and the Tomcat has also been used on that. And Nginx. Nginx is nothing but load balancer. I can say mainly it's called as a load balancer, but there are other functions also we can do. It can also work as either. What all things it is doing? It can do the web serving, reverse proxying, caching, load balancing, media streaming, and more. So can also work like an email and a reverse proxy and a load balancer for the HTTP, TCP, and UDP servers like that. So we need to know about the Nginx also. Nginx will be in the front, Apache Tomcat will be in the behind. Means Apache Tomcat will be the service. Nginx as a web server, we can even create Nginx as a web server also. Okay. Goal behind Nginx was to create the fastest web server around and maintaining the excellence is still central goal of the project. Since the original release, our websites have expanded from simple HTML to the dynamic and multifaceted, grown along with it, and so many things has been improved. And can do that. Which one has been like Nginx Plus? The FI guys purchased this Nginx, though they developed something called Nginx Plus. We may require a license for that, but we don't require to know that. But we just need to know how the Nginx is operating. So certain extra features has been added to the Nginx Plus, so that we require them some evaluation licenses available. If you take that and we can work on. And Nginx Plus has been used by this Dropbox, Netflix, and Zynga. More than 400 million users worldwide using the Nginx Plus and Nginx open source. And these are all the like theoretical things about the Nginx offers, ebooks, webinars, videos, and other thing. Keeps evolving. Is the forefront of development of the modern web, something like that. And software balance, and I guess if somebody is using their mic, you can mute your mic. Okay, thank you. And software load balancing, we just need to talk about the software load balancing because in Nginx there is no hardware installed in this. We will be using it as like a virtual machine only, or we can even run it in a container like that. The Nginx can be run in a container, Docker container, it's possible. So they are talking about that how the software load balancing is helping us dramatically reduce the cost without sacrificing the features of the performance. Moving to the DevOps requires software app delivery and deploy everywhere with the one ADC solution. Adapt quickly to the changing demands on your applications. No artificial or contract-driven constraint on performance. These are all Nginx Plus what they can do like that. And what are the load balancing techniques, methods which we can use in this? Round robin, least connections, least time, hash, IP hash, random with 2 choices, something like that we can. Maven, yeah, now we are going to talk about something on the coding side. Maven is a project management and the comprehension tool that provides the developers a complete build lifecycle framework. Development team can automate the project build infrastructure in almost no time as Maven uses a standard directory layout and a default build lifecycle. In case of multiple development teams environment, Maven can set up the way to work as per standards in a very short time. As most of the project setups are simple and reusable, Maven makes life of a developer easy while creating reports, checks, build, and testing automation setups. So that is Maven. Maven using this all building, it'll do the builds, it'll do documentation, it can do reporting, dependencies, SCM, source code management, it is called as releases, distribution, mailing list. To summarize, Maven simplifies and standardizes the project build process. It can handle compilation, distribution, documentation, team collaboration, and other tasks seamlessly. Maven increases the reusability and takes care of most of the build related tasks. So you may be having a very strong question in your mind. Am I going to do any kind of a developing here? No, we are not going to develop anything like because Maven is giving some set of commands for us. The way it is going to get build or something. You just need to know about how the building has been happening on this. So we just need to know about some of the directories and other thing, how to start the build and other thing. If you know that can be the Maven projects can be easily deployed in the Jenkins. I will be showing that It's very easier. Mostly like you will be doing it to the GUI only, so no need to worry about this Maven. Okay, evaluation, and evolution and objective and other things are there. Objective is like primary goal of Maven is to provide the developer with the following: comprehensive model for the project, reusable, maintainable, and easier to comprehend. Plugins are tools that interact with this declarative model. Like this. So we will be talking mostly about this project object model, POM file, pom.xml. We'll talk. Features: consistent usage across all projects, dependency management including automatic updating, large and growing repository of libraries, extensible JavaScripting and other things. So many other things are there. We will see something in very much in the elaborative when we come into the Maven. Maven may be like going for a 2 or 3 sessions be required. At least 4 to 6 hours required for to finish the Maven. We will do that Maven, don't worry. And the backward compatibility, automatic parent versioning, parallel builds, better error and integrity reporting. These are all we can do. Jenkins. Jenkins is a leading open source automation server. Jenkins provides hundreds of plugins to support building, deploying, and automating any project. It's nothing but the deployment software that is called as a Jenkins. Self-contained open source automation server, which can be used to automate all sort of tasks related to building, testing, and delivering or deploying the software. Can be installed through the native system packages, Docker, or even run a standalone machine in a JRE installed. Jenkins can be installed in Windows also, and it can be installed in Linux also. Okay, no worries. Because Jenkins is going to be mostly operated from the GUI based only. We will be operating it through the browser. Mostly Firefox will be perfectly working with Jenkins, so we'll do that. What are things that can be done with the Jenkins? Continuous integration and continuous delivery, plugins, easy installation, extensible configuration, distributor. Manage Jenkins. We are going to manage only that. Again, I'm saying that as a DevOps guy, means like an operation guy, we are not going to write the code. Whenever the people finish the code and they're giving it to us, we will just try go for a deployment model of this. The most administrative task can be performed from the screens in the manage Jenkins section. Means you just need to configure the Jenkins properly. So that can be given from the manage Jenkins option. And monitors that can alert you the new version of the Jenkins software security update is available. So what we do, we will be installing the Jenkins in a Linux platform and we'll see the screens which are there. Maybe it's coming up in the next slides or something. System configuration group, we'll see the configuring system, global tool configuration, manage plugins, manage nodes and clouds, configuration as a whole. And a security group, global security, manage credentials, configure credential providers, manage the users. These are all coming up. System information, system log, load statistics about Jenkins. We can see all these things. So tools and other things, you can just say Jenkins CLI, script console, prepare for the shutdown. Like that. This is how the Jenkins dashboard will be looking. These are all the projects which are running on this. It may be running with a different deployment model which has been there. So we will use this dashboard for this. I logged in as a Jenkins over here. And these are all the projects which are there, whether they are run properly, successful or not successful. Like that they will be using that. We will be pulling the code from the GitHub also. We'll be pulling it from the local repository also. We can run many of the projects, means like we can even deploy the projects using the Jenkins on this. So the managing the Jenkins, that's what I was talking about, configuring the system, global tool configurations, managing the plugins, manage the, like nodes and the clouds and other things. Like we can just do all this. Jenkins plugins. Plugins are required for us to involve certain projects need to get deployed in the sense. Those project dependency files are there. Those are all called as plugins. We have to install the plugins. So that plugins, we can go with the manage dashboard, plugin manager. We can install the plugins on this one. It's all very simple, like the way we are going to install it out. No need to worry about it. Everything will be mostly on 90% of the Jenkins are done through the GUI only. So no need to worry. Ansible. Ansible is automation tool, network automation only. We've been using that. I am using that. I can just say servers also can be automated. Applications can be automated. People are using it for a database also. I don't know. So Ansible is an open source automation tool or platform used for IT tasks such as configuration management, application deployment, intra-service orchestration, and the provision. Automation is crucial for these days. IT environment that are too complex, so many blah blah things. And advantages of the Ansible, it is a free, it's an open source tool, very simple and set up and use, powerful. flexible, agentless, efficient. You don't need to install any agent into the systems. Means like a Cisco router, Juniper router, Nexus boxes, nothing is required. Means like you don't require to install any agent over there. No need of installing any softwares. Like to support the Ansible or something. Only thing that target boxes require the SSH activator. That's it. Ansible will take care of everything. What are the features and capabilities? Configuration management, application deployment, orchestration, security and compliance, cloud provisioning. These are all things can be done. Configuration management, which we can configure the entire box of 1,000 boxes with just one code. It is possible. That is a configuration management. Simple data descriptions of infrastructure and both readable by the humans and parsable by the machines. It's very easy to write the code in Ansible. People have already got a lot of experience on Ansible. So it's like in English only it looks like. Application deployment. In other words, you won't have to configure the application on every machine manually. When you can run a playbook from your control machine, Ansible uses SSH to communicate with remote host and run all the commands. Orchestration involves bringing the different elements beautifully run whole application similar to the way the musical conductor is doing something. For example, application deployment, you need to manage front-end and back-end services, but the databases, network servers, so on. You also need to make sure all tasks are handled by the proper order. Ansible uses automated workflows, provisioning more to make orchestrating takes easy. That's what you'll be using it through that. Security and compliance, it has been there because we are using only the SSH to that. So we don't require to have some kind of think about the security now. Cloud provisioning also can be done by the Ansible. We can do that. Networking, supporting the network means like what all the boxes are supported by the Ansible. Almost every other box which is available in the world is being possible. We can manage it through the Ansible. A10 network, Abstra IOS, Arista IOS, Heavy Network, Big Switch, Cisco, entire Cisco platform, Cumulus Network, Dell EMC, FI, Big IP, 40OS, Junos, Lenovo, NetWise, OpenSwitch, Palo Alto, everything you do. Modules, plugins, inventories, and playbooks and APIs. Modules are the one small programs. We just need to install it in an Ansible master. There is a modules you need to install so that it can support the remote hosts accordingly to its own OSs. Plugins, many other tools and platform plugin are extra pieces of code document functionality. Number of plugins you can write on your own will. Inventories, that is nothing but how many machines we are going to manage it. That is nothing but a host file we can call. Playbooks are the YAML books which has been written, which will be running the automation script on the box itself. Like that is nothing but a playbooks. APIs, application programming interfaces are available so that you can extend Ansible's connection types, not only by using the SSH or something, you can use APIs also. These are all the docs. You can go through the documents to read about the Ansible in detail. Like Ansible is one of the platform which can automate your network because I'm from the network side. I'm just saying that. Next is a Docker container. And now we come to this real hard-hitting factor that we need to learn about the Docker. Docker is completely software which cannot be compared with any other things that are as such. We need to understand what is a Docker, what is a container, what is a virtualization, how the virtual machine is working, what is the CPU working on, what is the memory we are going to give it, how much network cards going to be inserted on this, what is the IP address we are going to give that, how we are going to talk about the containers, because these containers are going to stay in one of the operating system inside only, so we need to know the operating systems properly. Introduction to Docker. Docker is a containerization platform that packages your application and all its dependencies together in the form of containers to ensure your application works seamlessly in any environment. Container 1 and container 2. You see that host OS is in the down. The Docker engine manages all these things, application 1 and application 2. The containers which are coming into its own binaries and libraries so that you don't need to go and search for all these things and all. And it is very much easily portable, means you can transfer it to another machine very easily. And in simple words, Docker is a software containerization platform, meaning you can build your application, package them along with their dependencies into a container. Then these containers can be easily shipped to run on any other machines. These containers use containerization, which can be considered as an evolved version of virtualization. Same task can also be archived using virtual machines. However, it is not very efficient. What is virtualization? Is a technique of importing a guest operating system on top of the host operating system. Means you require one host, then you can install the guest into it. And they require multiple operating systems can run on a same machine. Maintenance and recovery very easy in the case of failure conditions. Total cost of ownership also less due to the reduced need of infrastructure. This is the advantages of the virtualization. Virtualizations run like this. Host OS is there, hypervisor is managing all this. Guest OS 2, guest OS 3 means Linux, Windows, and another Linux, something like that. I'll be doing that. But everything is being treated as a one virtual machine itself. It has got its own CPU, memory, hard disk need to be allocated for that, and has some shortcomings. Running the multiple virtual machines in the same host operating system leads to performance degradation, because guest OS is running on the top of host OS, which will have its own kernel and its set of libraries and dependencies. This takes up large chunk of system resources, hard disk, processors, especially RAM. Another problem with the VMs are takes almost a minute to boot up. This is very critical in real-time applications. Running multiple virtual machines lead to unstable performance. These are all the drawbacks. Hypervisors are not efficient as a host operating system. Boot up process takes long time. What is containerization? Technique bringing the virtualization to the operating system level. While virtualization brings the abstraction to the hardware, containerization brings abstract to the operating system. Do note that containerization is also type of virtualization only. However, most efficient because there is no guest OS here. We are not talking about the OS at all. There is no OS as such. It's having only the application and libraries and the binaries. That's it. That's all. It uses the host operating system to run other things as well. And advantages of this, like you see, containers are the application, binaries, and libraries. Container engine is here. There is no OS as such. There is no separate OS has been installed on this. A better resource utilization compared to VMs. Boot up process is short and takes few seconds, like this. In the diagram, you can see there are host operating system which is shared by all the containers. All people are using the same host OS only. Containers only contain application file specific for libraries, which is separate for each container, and they are faster and do not waste any resources as such. All containers handled by the containerization layer, which is not native to the host operating system. Hence, a software is needed which can enable you to create a new containers on your host operating system. This is how you just need to see the difference here. So this is a total memory of 16 GB. In case of virtual machines, you see that 6 GB allocated, 4 GB allocated, 6 GB allocated. In that one, memory used is only totally 9. You can just see the green color. Not the green color, it's a blue color. You can see. Okay, it's a blue color. 4, 3, 2 only used. What is remaining? 2 GB is remaining. Here 1 GB is remaining. Here 4 GB is remaining. These are all not used. Actually, when you assign the memory to the virtual machine, in the sense it has been hard coded to the virtual machine, it cannot be released at all. But that is not the case in the Docker. Docker will be using dynamically the memory is being allocated by the host OS itself. That is the advantage of this. So only 9 GB of memory is utilized. 7 GB can be allocated to the new container. So these are all like what I say, advantages of this. Startup will be very easily started up. New build can be started very easily. Since a container runs on your host OS, you can save precious boot up time. This is a clear advantage over the virtual machine. And this is the explanations again. Like so many containers are there over here, and Docker engine is controlling all these things. Each application will run on separate container and will have its own set of library and dependencies. This also ensures that there is process level isolation, meaning each application is independent of other applications, giving the developers surety that they can build applications that will not interfere with one another, like this. What is Docker and why Docker is needed? Docker is a containerization platform that packages your application and all dependencies together in the form of Docker container to ensure your application works seamlessly in any environment. What is container? Standardized unit which can be created on the fly to deploy the particular application or environment. It can run on Ubuntu container, CentOS container, fulfill the requirement from the operating system point of view. Also, it could be an application-oriented container like Kik PHP container or a Tomcat Ubuntu container. Benefits of Docker. Now the QA team need not to install all dependent software and applications to test the code. Also ensures that working environment is consistent across all the individuals involved in the project. Same thing they are going to use that. Number of systems can be scaled up easily, and this code can be deployed on them effortlessly. So we can pull all the images of the Docker images from the Docker Hub. You can visit this kind of dockerhub.com. You can go and download all the things, and you can integrate it with your own operating system to create the applications like that. So in Linux, we will be installing the Docker like this. In Windows, there is one more Docker host will be there. There is a Docker toolbox is installed extra. In Windows and OS X means Mac OS. Here in the Linux, there is nothing as such. REST API only will be. What is the Docker image? We are pulling the image and we are going to install that to the Docker. Docker container, Docker images are created and build the command. These read-only template are used to create the containers by using the run command. Docker lets people create and share software through the Docker images. What is Docker container? See that Docker images make the container, which is installed, fully installed application like that. You can say running instances on images, then hold the entire package needed to run the application. This happens to be the ultimate utility of the technology. And what is the Docker and everything? The architecture, something like this. You see Docker client, Docker host, Docker registry. So these are all theoretical things you don't understand very easily. Just to lab practice by doing that in your own hands, creating the images, pulling the images, like creating the containers and run it and seeing it and porting it to the another machine and verifying that. You would like to see that what is the IP address has been configured for that one. Like that, we will be seeing many other things, so you'll be easily understanding the Docker architecture. And about the architecture in the sense, like client server applications, the three major components. Server, which is type of long-running program called daemon process. REST API, which specifies interfaces that programs can use to talk to the daemon and instruct it what to do. Command line interface clients. CLI uses a Docker REST API to control and interact with the Docker daemon through scripting or direct CLI commands. Many of the Docker applications that are using the underlying API and the CLI. Okay, that is about the Docker. It's a single Docker images. We are going to take that as a container. We are going to create it. But how we are going to manage it? Managing in the sense, if there is a Docker means it is going to take only the small space. Say for example, a simple application has been taken as a Docker container, which is going to have some around 150 MB or 200 MB or something like that. That application is running perfectly. Like, okay, if you like to run that as a multiple instances, like, so the same Docker image, Docker container, would like to run it in a huge scale, means a 10,000 to 15,000 Docker container I would like to run. How I am going to manage it? There we require a kind of orchestration software. So Kubernetes is one of the orchestration software which has been most acclaimed all over the world. Everybody is using the Kubernetes to manage all the Docker containers. You see that Docker. Kubernetes is on the top. Is an open source system that handles the work of scheduling the containers onto the compute cluster and manages the workloads to ensure they run as a user's intents. Being a Google brainchild, it offers an excellent community and works brilliantly with all cloud providers to become the multi-container management solution. That is nothing but the Kubernetes. Automated scheduling, self-healing capabilities, automated rollouts and rollback, horizontal scaling and load balancing. These are all the features of the Kubernetes. This is like an orchestration platform. This is going to manage your entire Docker containers, which are spread across so many server farms like that. Automated scheduling, self-healing capabilities, automated rollouts and rollback, horizontal scaling and load balancing. These are all the things. Advanced scheduler launch container cluster nodes. We will be seeing how the architecture has been there for Kubernetes has been containing like that. Self-healing capabilities. It also kills the containers that don't respond to the user-defined health check. Like that. We have that kind of a mechanism has also been built in. Automated rollouts and rollback. It's possible. Load balancing also it can be. Architecture. One is like a master node and a worker and slave nodes. There are two kind of things of that. Master nodes is responsible for the management of Kubernetes cluster, mainly the entry point of the all administrative tasks. There can be more than one master node to check out the fault tolerance. That is possible. We can create multiple master nodes. And as you can see in the diagram, the master node has various components like a API server, controller manager, scheduler, and etcd. API server is the entry point for all REST commands. Controller manager, daemon that regulates the Kubernetes cluster. Scheduler schedules the charge tasks to slave nodes, stores the resource usage information. etcd, etcd we call this. etcd simple distributed constant key value store, mainly used to store the shared configurations and the service discovery. Worker and slave nodes. This contains like a Docker container, kubelet, kubeproxy, and pods. Contain all necessary services to manage the networking between the containers, communicate with the master node, and assign the resources to the scheduled containers like this. Docker container, Docker's containers will be there in this one. Kubelet, configuration of the pod from the API server that ensures that the described containers are up and running. And the kubeproxy acts as a network proxy and load balancer for a service for a single worker node. Pod is one or more containers that logically run together on a node like this. So this is how increase the human cost of service, increases the complexity of the running something in the new production, setting up new services manually like this. So now to avoid setting up the services manually and overcome the challenges, something big is needed. That is where the orchestration container has been coming to the picture. So scaling was difficult. Manual work of like fixing if the node is crashing, increases the size of bills for the public cloud providers. So we require to have kind of a mechanism though that it can manage all the containers. That is a Kubernetes. Open source container management tool which automates container deployment, container descaling, scaling, container load balancing. Written in Golang, the language. It's a huge community because it was developed by Google now, later donated to CNCF. Can group n number of containers into one logical unit for managing and deploying. This is how the master is working. This is how your, how things are getting managed on this kubeproxy kubelet. This is your worker node, we can call it as like key value store, scheduler, API server, controller. The person is talking to us. So we will see that in a practical so that you will understand easily. Master nodes, worker slave nodes, distributed key value. You've seen that already. This is the controller manager. And this one is an API server. And this is a scheduler. How does it work? Like etcd is a distributed key value store which stores the cluster state. It can be part of Kubernetes master. It can be configured externally. etcd written in the Go programming language. Like that. Worker node, there is something extra explained about the worker node. We have an external world which is talking to the kubeproxy. Kubeproxy will be talking to the pods as well as the container runtimes, and the kubelet has been there. Container runtime, kubelet, kubeproxy, and pods. Container runtime, to run and manage a container lifecycle, kubelet. It's an agent which communicates with the master node. Kubeproxy runs on a node that deals with the individual hub host subnetting and ensure the services are available for the external parties. Like that, it's like a proxy it has been working on. Pods, one or more, something like that, we can call it as like a pod. Okay, that is about the Kubernetes. Very quickly, I just given that, but it's not so quickly we can go far. But anyway, we just need to see that at least 2 to maybe 4 sessions, maybe it takes for to understand the Kubernetes along with the container Docker containers. We will install it and we'll see that. And Terraform. Terraform is mostly used for cloud platform automations, I can say. It's a tool used for changing, building, versioning infrastructure efficiently and safely. It is used for managing the existing and popular service providers or custom in-house solutions. The components running for a single application or entire data center configuration file is described to the Terraform. Execution plan is being generated by the Terraform, which defines what it will do to reach the desired state and executes the build described infrastructure. Means if you like to create something, a set of machines from in the AWS in the sense, we can use the Terraform. In which region you would like to create and what is the OS we'd like to have. Like a cloud formation template like that, we can create a Terraform. What is special in the Terraform in the sense, cloud formation has been given in the AWS. It can work only in AWS. The same kind of a template, if we try to use it in Azure or in the Google Cloud, it doesn't work. There, Terraform comes into the picture. We can use the Terraform as a uniform code can get deployed in the multiple OS platform, multiple cloud platforms as well. The Terraform is infrastructure as a code. It is a tool to manage virtual server life cycles, AWS, VMware, and other things. It is a tool to manage your supporting services, tool to manage your system services. Configuration files can be SQL or JSON. You can write in JSON. created by the HashiCorp, written in Go, but still it is a open source only. Why Terraform? DevOps, the main goal of DevOps is to perform more efficient software delivery and to make delivery efficient and quick. We need some tools in Terraform, like which helps companies as with infrastructure as a code and automation. Changing to the DevOps world by changing the way infrastructure is being managed makes faster and more efficient for executing the DevOps. There are existing technologies like Ansible, Chef, and Puppet for automating and provisioning software. These are all still there. Chef and Puppet has been nobody is using now. Ansible we are using that. Terraform also uses the infrastructure as a code, but it targets automation or of infrastructure itself. Complete cloud infrastructure like instances, IPs, volumes, networking can be defined very easily with Terraform. Advantages: orchestration, multi-provider. This is a very important point. Multi-provider, immutable infrastructure, syntax. HCL syntax is there. Dry runs, client-only architecture, and super portability. Dry runs you can do without installing anything. You can just see that how does it going to work like. Multi-provider, it can work with AWS, Azure, OpenStack, Google Cloud, everything you can do with it. Immutable. Every change in configuration leads to separate configuration snapshot. Like that. Syntax, we can use a JSON syntax, HCL syntax on this. Dry runs, Terraform plan, which creates an execution plan. By using this execution plan, we can check whether the set of changes meets expectation. Like that. It is not going to install anything like that. It will say that whether it is going to work or not. Client-only architecture, super portability. These are all the providers: AWS, Azure, Google Cloud, Alibaba Cloud, Oracle Cloud, Kubernetes. Even in Kubernetes also we can use Terraform. And this is Oracle Cloud, Microsoft Azure, the same diagram, something with some like logos or something. Modules, configurations, providers, modules, Terraform registry. You can go with all these things. Multi-cloud deployment provisioning means one code can work with multiple cloud operators. That's what. Just to write only one code. That code you can apply to the AWS also, Microsoft Azure also, Google Cloud also, Alibaba Cloud also, like that. And reproducible infrastructure as a code. Implications of the cloud operating model is the vSphere hardware, IP hardware, vCenter dynamically. You can go with the run, connect, secure, provision. Like this. AWS, it comes with the EKS and ECS Lambda, cloud map and app mesh in a various hardware, identity as an IAM, cloud formation. It can work with that. Unlocking the cloud operating model. Not only the Terraform, they have some different products as well, like a Vault, Consul, Nomad, like that. It's a security automation can be done by Vault. Network automation can be done by Consul. It's like an Ansible, like that. Nomad. Application automation can be done with a Nomad. Like that. This is how it has been working on. Runtime, networking, security, infrastructure. Infrastructure is coming as a Terraform. Security is on the Vault. Networking is on a Consul. Runtime is a Nomad. Right? So we can run the Terraform in any platform: Mac OS, FreeBSD, Linux, OpenSSD, Solaris, Windows, everywhere you can install Terraform Cloud. Terraform. We can run the Terraform in AWS, Microsoft Azure, Google, everywhere you can install. The last one is nothing but the Sonar Cube. Sonar Cube is an automatic code review tool to detect the bugs, vulnerabilities, and code smells in your code. It can integrate with your existing workflow to enable the continuous code inspection across your project branches and pull requests. This is nothing but a testing. We can do any type of any damn software which already has been written as a code or something, we can put it on this and we can do the testing. So the testing provided by the Sonar Cube. We can have the Sonar Cube, we can install it, and we can see that how the things are working on. Sonar Lint, it has been called as. You see the checkout, build, run, test, and scan. Through the Sonar Cube, it goes on notifications, you correct it and commit the merge. Analyzing the review. Once Sonar Cube platform has been installed, you are ready to install a scanner and begin creating the projects. To do that, you must install the configure the scanner for your appropriate needs. Gradle for Gradle, .NET, Sonar Scanner for .NET, Maven, Jenkins, Azure DevOps, and anything else, CLI, Sonar Scanner. Sonar Cube integrations are supported for popular DevOps platforms like GitHub Enterprise and GitHub.com, Bitbucket Server, Azure DevOps Server, Azure DevOps Server services. So this is nothing but like code correcting platform. We can take it as like, Sonarqube is going to find out your bugs in the code, and it is going to deploy that, and it is going to show that as a notifications to you. So you go and correct your mistakes and redeploy it again. So what are the requirements like? How do you install it as a Sonarqube? You require a Java as usual. Hardware requirement, 2 GB of RAM is required. 1 GB of free RAM for your OS something. Amount of disk space in it will depend on how much code you are analyzing with the Sonarqube. It must be installed on hard drives that can have excellent read and write performance. Most importantly, data folder houses Elasticsearch indices, which a huge amount of I/O will be done, so that you require to give some more spaces to it. So installation will be very pretty easier one. So let's see that it's 4 codes nulls as done, and vulnerabilities are 1. Then it is saying that it has been passed. Now your code has been passed, so that you can go and deploy it. Enhance your code quality and code security. Release the quality code, application security, technical depth, like that. And how many programming languages are supported by this Sonarqube? 29, I guess something they're saying. You see that Java, Kotlin, C, VB, C, C++, PHP, Python, Terraform, ABAP, Apex. So many other languages are there, like this, SQL and Scale and HTML5. Everything has been done. So these are all support on this. CI/CD integration can be done with the Sonarqube, and feedback can be given in the Bitbucket, GitHub, Azure DevOps, and GitLab. Sonarqube can analyze branches of your repo and notify you directly in your pull request. And it can be installed as a community version, which we are going to install it like a community version only because it's a free one. Developer edition, the person who are a developer should be installing this. Enterprise version, data center version, everything is available. We can take the community edition, we can install that. CI/CD is nothing but continuous integration and continuous deployment, development, like that we just call. So we've seen many other tools and deployment platforms, Git and GitHub, deployment tools on the cloud, deployment tools on the local platform, on-premises, and other things which we see as a total DevOps like this. So this is about DevOps from my side. What I'm going to talk about that in the coming up sessions. And if you have any questions, you can go ahead and ask me. I'm going to answer your questions on this, about the sessions, lectures, timings, and the prerequisites for to come to this course or something. Whatever the questions in your mind, you can ask me. It's all up to you. You can unmute your mic and you can talk to me, no problems. Go ahead. I spoke near about more than 1 hour, I guess so. So ultimately, what I'm saying that this is a new environment for everyone, including for me. It is not the one which we known already. Known in the sense like that, even we are starting with the Linux. So most of the people doesn't know about the Linux also. We are going to start with Linux. And patience is required to understand the tools, to understand the software infrastructure, how to run, how to test, how to see the errors which are coming up on this, to document it properly, to understand that. And before putting that into your resume, that these are all the skills you have, that you need to attain those skills literally by practicing on your own and understanding all these things. Okay. So these are all the things which are required to be prerequisites, I just say, because everyone is around 5 to 6 years of experience in the industry. So better you can ask your question. That's how you see DevOps. Test, release, deploy, monitor, plan, code, something like that's been coming up. So it is more of a development platform. People are talking about that, but we are in a position to learn these things. And literally, I'm just saying that you are not going to do any kind of a code hard-codedly. You are not going to do any coding or something. You will be doing some kind of operating platforms like that. That is in operations. It comes in the operations like that. Development, then operations. We'll be talking more on operations side. Okay, that's all from my side. If you have any questions specifically towards any kind of packages, any kind of tools which you talk about, that you can ask me, or overall, like whatever you're thinking in your mind about the DevOps sessions, you can ask me. It's all up to you now. I'm ready to take your questions. Thank you.
Ramnath, you have given a brief overview. Thank you very much for that. And I have a doubt. That is what, let's say we're gonna start a session. So how you're planning to do practicals in? I mean, concepts we understood up to a certain level. So eventually we'll understand the concepts. But if though we understand the concepts, so it will be inculcated to our brain cells or the blood. So once we work with the practical environment, once we get the hands on only, right? So how do we get the hands on? What's your plan to give us the hands on? So
Correct.
how do you plan it to
Correct. Like
practicals?
everyone must be having a PC at least 8 GB or 16 GB installed in their own operating system. Like Windows is okay, no issues. Windows 10 we require. We will be installing the VMware workstation. On that, we will install the CentOS box and the Ubuntu box. Ubuntu normal 18 something like that version is there, 20 version is there. Anything we can take there. Those Ubuntu and the CentOS doesn't going to take much of the resources from your boxes or something. 4 CPUs, 2 CPUs if you give, it's more than enough. And around 4 to 6 GB if you give that, more than enough. 100 GB you give it for each virtual machine, it's enough. So we will be doing all the practicals on your own machine in the Ubuntu or the CentOS boxes on this. We can take the SSH from the Windows and we will be running all the installation of all the softwares. We will see that. And even we can do that AWS EC2 Linux instances for to practice some other things. But I will show that in the later part. I will not show it on this because you just need to have the complete proper knowledge on the Ubuntu or a CentOS platform. So we will see, we can even see it in the AWS platform also. It is not an issue. So what the minimum requirement I just say, if you come up with the 16 GB machine with at least 200 GB free, and like i5 or i7 processor will be fine. So we will be installing 2 virtual machines. One is Ubuntu, another one is a CentOS. So we can see it in the multiple platforms, how do they operate. And each virtual machines will be having at least 2 CPU installed, 2 virtual CPUs, and near about 3 to 4 GB assigned to that, and 100 GB software, 100 GB hard disk assigned to that. Only this much is we require. We require very minimal thing. We don't require heavy things or something. And of course, we require internet connections for that. So we have to download certain software and installing, configuring, verifying all these things over the internet. So we require. So there is a very minimal requirement. We are not going to look for any kind of boxes or OS need to be downloaded, something like that. We just need to get it from here, there. No, everything is open source. Everything we are going to download it from their own respective sites only. Apache Tomcat, Nginx, Jenkins, Maven, and Linux also. Like we'll be downloading it legally from their own websites, and we'll be deploying it. I will be helping you to install the Linux boxes in your own machine as a virtual machine. I will configure it and tune it and give it to you that you can start using that to learn the DevOps sessions. Is it clear?
You mean including the orchestration tools also, right?
Of
Like
course, yes. Of
Kubernetes.
course, orchestration we may require to give something more. If you are going for a Docker and Kubernetes, we might increase the memory to 6 to 8 GB. 8 GB require for Kubernetes, I can say that. At the time of Kubernetes only, we may require some more. That's it. Otherwise, no.
Yeah. Docker already running.
Yes. Minimum, everyone is having nowadays i5 with 16 GB DRAM and 1 TB hard disk they are having it. That's more than enough for us. Only for Docker and Kubernetes, we may require at least 6 to 8 GB of DRAM has to be allocated. Then we can see easily and we can enjoy the things, how do they are working to see that. Or if at all not possible, I'll try to show it on the AWS platform. But at that time, we may have to go for not the free tier machines. We may have to pick up some high quality, higher end configuration machines. We need to pick it up from the AWS to install the Kubernetes and seeing the practice. That I can show you. That way we can do it.
So that how much will it be, that server?
Which,
I mean, we have to make use of it for a certain period, right?
So that's what, see, 8 GB you are going to take that, and the per hour charges, you can just see that 8 GB, maybe maximum 3 to 4 hours we'll be working on. So you can count the charges. That's not be so much heavy. It will not be so heavy for you. Once you've done the practice, you record it, you took out all the like the logs and other things, it's enough. You can do that. But 8 GB, if you can give it from your own machine, 8 GB if you allocate, it's more than enough. It can work. 8 GB DRAM on top.
Okay.
because we require to
Thanks.
create a cluster in terms of Kubernetes means Kubernetes will like a master node will be on a one machine and worker nodes will be on another one. Containers will be running on this here and there. So we require to have that kind of environment, like a pod. We just need to create. That's why.
Yeah, we have to have at least two nodes, right?
Yes.
One master node and one
Yes.
worker node.
Like
So
that.
in that worker node, that Kubernetes pods are running. I mean,
Yeah, right. Correct. So, any other questions from anyone? You can ask me freely. No problem at all.
Ramnath Bimal here.
Yes.
Can I know what is the mainly focus into which areas? Is it Kubernetes and Dockers or the actually this is very new to this field, and I realized I didn't know lots of things.
Right, I know. Everyone, not only you, whoever is joined today the meeting, that everyone is looking new only. No worries about that, but we are not. We will be giving the equal importance to all the tools we are going to learn. Either it is a Tomcat or an Nginx or a Terraform, maybe like Ansible again, or Kubernetes, a Docker. Everything will be seeing it in their own respective time, and we will be giving the quality time for to learn all these things. No worries. Nothing is a number one. Nothing is a number two. Like that. Everything is a number one.
Actually, I have experience. I followed your previous AWS class as well. So you did very well, and you done everything in deep. You did all the practicals, and you didn't think about like that. Your timing, those things. But I asked, I didn't know about that DevOps things. That's why I asked that question.
Same we will be doing because installing and tuning doesn't take much time in Apache Tomcat and Enginex and all. Okay, don't worry about that. We will still, if you don't understand, we'll do that, redo that again. No issues at all. I am not looking for any timing constraint or something here. Ultimately,
yeah, actually, yeah, time constraints and all, no argument on that. You're giving solid time for our efforts. So I really appreciate those things. And the other thing, let me add one thing. So to be honest, I applied some jobs in Europe side. Now network engineers also, the routing and switching is a basic requirement only. What they ask Kubernetes, Docker, and some Linux also, and clouds, because there's no, I mean, what I understood, there's no on-prem, all cloud, either Azure, AWS, mostly AWS, sometimes Azure also. That's I have decided. And then thereafter, that's not enough by knowing AWS only. So we should know something about DevOps side, at least. What do you call Docker, Kubernetes, or Docker Swarm? I think you're not covering Docker Swarm. Docker Swarm is not being used now. I mean, mostly asking Docker and Kubernetes, because so we can get even visa by being Sri Lanka itself if we know the network engineering side. By knowing this, even system engineering, that they're asking that programming side also up to a certain level, and Linux, Ansible also as well. Ansible everywhere they're asking. If I choose network engineer jobs 10, at least 8 or 9 they will ask Ansible.
Of course, yes.
I experienced it.
Sysadmin
That's
guys
why
required to know. Sysadmin guys required to know about Docker and Kubernetes because it is installed in the servers only. That's why.
Yeah, your teaching style really impressed, but though I don't think that your demonstration that people will see very, I mean, high value on that. But your all the classes, I'm really happy. That's why I have decided to go behind you and catch one more time to learn these things, that because we are in the industry, so we cannot spend that time for self-learning and all. So it takes so long. So if we follow the proper way to study the thing, so then that will be easier for us to understand, and that will be so we will be able to reach our goal very fast.
Right. Thank you very much.
Also, Ramnath, sometimes I can give a recommendation for about you for the newly joined guys to hear, because sometimes they can see your demonstration is very fast. Sometimes your classes also like that. But actually, it's not like that. Sometimes I'm asking the same question 3-4 times. You are logging to PC and correcting me every time. But
Typical
yeah, uh, actually, you're very good in your way to teaching.
Thank you.
I like to learn DevOps things very fast.
Okay.
Need to move that field.
Okay.
That's why I am interested.
We'll have our own time.
Okay.
No worries
Yeah.
about the time constraints. Yeah.
I think rather than wasting your valuable time, we had better give chance for others to also to ask questions, and we'll talk about that how we are planning to, if we are planning to go ahead. So how can we go ahead? And so guys, if you have any question, please do ask. Only myself, Ramnath and Vimal talking, and so we had better give chance others also to talk. Please, guys, if you have any question, please do ask.
Yeah. The long silence.
Anat, how many sessions you hope to do?
Maybe like, because each topic may be at least taking 3 to 4 sessions. Accordingly, you can just calculate that around 8 or 9 we are going to see that. So 4 sessions into 10. So maybe like 40 sessions. 40 sessions in the sense, like if it is a 4-hour session in the sense, we can make it 20-25 sessions. We can make that possible. As we done with the AWS and Ansible, the same speed will be going on. We can definitely finish that. Not an issue at all.
Okay, Ramnath, let's say as now you have shown us today what are the things that we have to cover if you are going to follow our DevOps course. So the most important thing, so if you are planning to go ahead with a DevOps session with you, DevOps full training session with you, so how much will it be your charges and all, because others also want to know that thing, right?
I myself is because confused like that. How much should I ask you guys? Like, because we will discuss it. That is not a bigger issue. Or we have a group, we can discuss on that. That's not a bigger issue. Like, because some of the tools you may not be requiring it as such. Like Ansible, we already covered it. I can just remove that. And Terraform, the people may not like it in the sense I can remove that. Like some of the sessions,
No, I
skip it out.
I think there's only I know Ansible and yeah, so a few other people. So if some people who join they don't know Ansible, and then we have to pay attention for that also, right? So by thinking about that also, we have to go ahead and do this training. Because thing is, yeah, um, I let's say assume that 10 people join the session or 15 people join the session. So almost, because some of the people who are not in this session, they were in previous sessions of you, so they're really impressed. Then they have already decided to join that session. That's why they didn't join this session, right? Okay, so yeah, as you said, we'll discuss those fee and all the things like that in the group. So whoever who's interested, I'll leave in the channel, and let's if anyone is not interested to go ahead, so they also can leave the group, no problem with that. And so we'll discuss in that group itself all the costing and all. So roughly how much, I mean, to give a rough figure for others to get an idea.
Because that people doesn't come for an entire session or something, they'll ask only the Kubernetes, they'll ask only the Docker. Somewhere or other they'll asking like. So that's what I was just also confused that how much I can charge for this entire thing, like for you. I will give you the figure, not an issue at all, by just seeing the modules which I'm going to cover on that. And we'll discuss it. That's not a bigger issue at all. Don't worry.
Okay.
I'll work out with that. No issues. As we agreed with that AWS as well as the Ansible session also. So.
Yeah, those we got a really reasonable rate. We are really happy about.
Yes.
That, and yeah, actually for AWS we only got 8K Indian rupees each. 8,000 INR. It was a very good price for us, because thing is AWS that's also took quite long time, like 3 months, like more than seems like 3 months. So
yeah, December we started, and Feb first week we finished it.
Yeah.
We'll do that. That is not a problem at all. And some other tools which I'm going to talk about that doesn't take much time also. Maybe like in one session also we can finish that. That's smaller, very smaller things are there. So the time is not at all a constraint as such. And pricing, definitely I will discuss it with you on the group itself. We will have an open discussion on that. And
Okay.
how many people are really concerned about the money part, and how many people are really concerned about getting the knowledge of something, accordingly we can go ahead with that. And most probably it will be a weekend session only. People will be looking for only weekend sessions, or how?
For me, weekends. How about others? Those who are planning to join.
Actually, if it is in the weekdays, also fine, Ramnath.
But for me, evenings okay.
Yeah.
For those who are, I mean.
But everybody.
So actually, Pradeep Hasante.
Yeah, Hasanta, please.
Yeah, actually, for this month we can go ahead with in evening session, but in next month we have at HCL we have afternoon sessions. That shift, then we don't have any time to participate. Me and Tilina. Yeah.
Oh yeah, you and Telina are planning to participate in the training, right? So we have to think about that. So you don't have any commitment in weekends, right? But
yeah,
still
actually
for
weekend I have time because Sundays and Mondays are my week off.
How about Telina?
If no more questions, I can go ahead and just end this session, and I will be sending this PPT to you, all the people. I'll share it in the group, or you can even send a mail to me on this one, stuckroute@gmail.com, to receive this the PPT, which I'm going to. It's around near about 140 slides of that. Okay, just take it out and go through that, because you will get some idea about that, what DevOps, how we are going to conduct it. Which is some other tools you may not be required. It's not an issue. You can pick up some other tools only, and then you can ask me, right? We can do that definitely. So you can tell me that if you have any questions, ask me, else I will be go ahead and close this session. And thanks for all the people who joined the session and spare the time to listen to me today, Saturday evening. Pradeep.
Yeah, Ramnath, thank you very much for your time. And I had a nice session. And so we'll go ahead and discuss in the group, so how we are planning to proceed. And based on that, so we'll start anyway. So we already confirmed few people. So based on that, anyway, we are going to go ahead with this training. Not a problem with that. Okay. So almost 10 people are there already. So we'll try to start as early as possible. Not next week. So I also need like 1 week because I also have some other commitments.
No problem.
So
Take your time and just confirm it on the group that we will start the day, fix the day, and then we will start the session. No problems.
Yeah. Okay.
Okay then. Thank you all. Thanks.
Okay. Thanks, Ramnath.